Scientists keep finding new planets they call super-Earths. It's a class of more massive planets than Earth, but way lighter than ice giants, such as Uranus and Neptune. Super-Earths can be made of rock, gas, or a combination of these two. They are often twice or even up to 10 times bigger than the Earth. They're interesting to study, but kinda too far away from us. They're pretty common outside of our solar system, together with other interesting planets like mini Neptunes. Those can also be gas dwarfs, ice giants, or huge rocky bodies. But again, we don't have anything like that. But something we do have that those other solar systems don't? Jupiter. It's the biggest and heaviest object that orbits our sun. This king of planets possesses a powerful force to dominate our solar system. Jupiter is notorious for eating planets. A protoplanet slammed into it about 4.5 billion years ago, when Jupiter was still a young planet in its early stages. This protoplanet was 10 times heavier than Earth and was made of ice and rock. The collision was huge. Jupiter's core broke apart, and helium and hydrogen mixed with denser materials. Through time, the heavy material settled back into the dense core, which is what we see today. And if it swallowed a planet before, it might keep doing it as well. We suspect our solar system used to have many more large planets than it has now. For example, it's kinda empty around Mercury today. Similar areas around many other central stars are definitely more packed with intermediate mass planets, with the size between Earth and Neptune. Our solar system was a chaotic place at its beginnings. Young stars were surrounded by swirling disks of dust and gas, and planets would form out of that debris, something like trees when they're springing up from the ground. Small rocky planets would form in the strong heat and light close to stars, while gas giants would form farther out, where temperatures were lower, which means they could preserve more gassy materials. And even though planets in our solar system seem pretty stable and peaceful today, following their orbit, they weren't that calm before. Some planets didn't have a circular orbit. They had oblong, more eccentric paths. It took them swinging first toward their stars and then farther away. It was like they had been thrown off kilter by the gravity of other planets on their way. There's something called the Grand Tack theory. It explains things happening in the first few million years when our solar system was forming. At some point, Jupiter, one of the key players here, may have been pulled in closer by our central star. After that, it went back and took a huge cloud of debris. It was like a sailboat when it tacks around a buoy. This kind of messed with planets that were in the process of formation. After Saturn was fully formed, our close neighbors in the solar system cleared out a little. But if the idea about Grand Tack is correct, Jupiter had grabbed everything in its way, and its migrations had caused more collisions in this area. Jupiter might have delivered some of the water that now fills the oceans we have on our planet. It shepherds plenty of asteroids. From time to time, it sends some whizzing into interstellar space, or amongst the planets in our solar system. It may have even taken part in the dinosaur extinction 66 million years ago. When the huge space rock hit the Earth, it left a crater off the coast of the Yucatan Peninsula in Mexico. It all caused earthquakes, volcanic eruptions, and tsunamis that made a huge impact on all animal and plant life on Earth. No one knows where it came from. We're not even sure if it was an asteroid or a comet. One theory says it may have been a comet that came from the Oort cloud, which is made of icy debris and is located somewhere at the edge of our solar system. It could have been bumped off course by Jupiter and its powerful gravitational force. This way, our solar system was like a pinball machine, where Jupiter, the biggest planet, kicks incoming comets into orbits that send them closer to the Sun. When these comets are near the Sun, they can go through strong tidal forces that break them apart and eventually create shrapnel-like pieces of a comet. That event was a point when our mammalian ancestors started to rule. That means without Jupiter, there might not be us either, nor the Earth. It seemed like our biggest planet came swinging in, destroyed older planets, and cleared the way for smaller worlds like ours. Jupiter may have been the reason why we can't find Planet 9 right now. Scientists believe it exists, and they think it could be hiding somewhere beyond Neptune, but not Pluto. There are 3 zones in our solar system: the inner planets, outer planets, and whatever there is beyond. The mysterious planet could be the size of the Earth or Mars. It swirled among the gas giants before they eventually swept it toward the outer parts of our solar system, or even somewhere into deep space. Jupiter has stripes because of differences in temperature, atmospheric gas, and chemical composition. Scientists used to think the only reason for these different colors was the mighty atmospheric wind and material circulating between layers of the atmosphere. Now we know the light-colored stripes, or so-called zones, show us where the gas rises. When the stripes are dark-colored, they're called belts and can tell us where gas is sinking. Jupiter's moons could also be why the planet is stripy, because they're tugging on its atmospheric convection cells. At the center of Jupiter, there's a dense liquid core made of helium and metallic hydrogen, together with dissolved heavier elements. As we go further from its center, the temperature and pressure inside the planet drop off. That way, the liquid interior gives way to gases from the atmosphere. Again, mostly helium and hydrogen. No one knows how deep this liquid-gas boundary lies, but the planet is probably fully liquid a couple of thousand miles under its cloud tops. Jupiter would still be bigger than some other giants, like Saturn, if we could strip its gases. Jupiter is sometimes even called a failed star, although that's not quite correct. It's mostly made of hydrogen, like regular stars, but it's still not massive enough to start thermonuclear reactions in its core, which would eventually turn it into a real star. In theory, every object could be turned into a star if you only add enough matter to it. If there's enough mass, the temperature and internal pressure will increase and start thermonuclear reactions. So, to turn Jupiter into a star, such as the Sun, you'd have to make it 1,000 times more massive. But to form a cooler red dwarf, you'd only need 80 Jupiter masses more. That way, Jupiter won't spontaneously become a new star of our solar system. But if many space objects with similar mass collide with it, or in other words, if Jupiter eats them, then maybe. You never know. But in theory, if it could become a massive star, it would have stopped other planets from forming in stable orbits. It would have also increased the radiation that the surface of those planets get, which is why it would be really hard for life to develop in our solar system. Jupiter is the planet that spins the fastest in our solar system. It only needs 10 hours to make a full rotation on its axis, even though it's huge, more than 300 times bigger than the Earth, and 2.5 times more massive than the rest of the planets in our entire solar system together. But if it got more massive, it would shrink. More mass would make Jupiter denser, which means it would begin pulling in on itself. So it could get 4 times its mass and would still be the same size.
Hey space buffs, just how well do you know our solar system? Guess the planet. It's more than twice as massive as all the other planets combined. It's covered with striking swirls and stripes, which are actually windy clouds of cold ammonia and water, floating in an atmosphere of hydrogen and helium. Still no clue? Then look at this. It's the infamous Great Red Spot, a giant storm larger than our home planet that has been raging for hundreds of years. Right you are. This cloudy world is Jupiter, and the main question is this planet our enemy or friend? NASA's Juno orbiter is exploring this gas giant at the moment, sending us tons of useful data. Jupiter is so big that 11 Earths could fit across its equator. If our planet was the size of a grape, Jupiter would be a basketball. The gas giant is the 5th planet from the Sun, orbiting around 484 million miles away. And even though for us Earthlings, our blue-green world seems to be the most important among all the other planets, we live in Jupiter's solar system. After all, it accounts for 75% of the mass of all the planets in our star system. And it's also 318 times more massive than Earth. And whatever Jupiter wants, Jupiter gets. Jupiter wants to throw stuff across the solar system? No problem. After all, this gas giant doesn't have its immense gravity for nothing. It yanks material from the asteroid belt, stopping poor space rocks from forming anything larger than Ceres, the only dwarf planet located in the inner solar system. Jupiter is hungry, it gobbles up comets, asteroids, and whatnot. Jupiter's bored. It hurdles everything it manages to capture on wayward trajectories. This gas giant must have caused a lot of destruction over the course of its life, which is around 4.5 billion years. But here's the thing. Some scientists think that we might owe our very existence and the existence of our planet to Jupiter's protective gravity. It may sound confusing, but by greedily swallowing up dangerous space objects, this planet vacuums the solar system. Other astronomers don't agree with this theory. They claim Jupiter is a hooligan, bothering peaceful and safe comets and sending them to unexpected places. You see, some of the most dangerous objects in our solar system are long-period comets. Those are huge chunks of ice and rock coming from the depths of the Oort cloud, which lies far beyond Pluto. Some of them get pushed into the inner solar system, where they dash past the sun. There's a chance that the most devastating extinction on Earth was caused by a long-period comet. As such comets make their way through the solar system, they likely interact with Jupiter's gravity. The gas giant pushes them this way and that, consuming some of them like delicious ice rock burgers. But does Jupiter push such comets out of their dangerous orbit so that they don't smash into Earth? Or does this gas giant actually divert the trajectories of the comets that would otherwise miss Earth? No one knows. Astronomers sometimes call Jupiter a failed star. The gas giant indeed contains a lot of helium and hydrogen, the material stars are mostly made of. But the planet's mass isn't enough to start a fusion reaction in its core, and that's exactly how stars produce energy. They fuse the atoms of hydrogen together under extreme pressure and heat and create helium. In the process, they also release light and heat. Jupiter could start a nuclear reaction and become a star only if it was 75 times its current mass. Paradoxically, if Jupiter even got more massive, it would also get smaller. This additional mass would make the planet denser, and it would cause the gas giant to start pulling it in on itself. Astronomers are almost sure that even if Jupiter was 4 times its current mass, it would still remain the same size. Jupiter has between 80 and 95 moons, but one of the most popular ones these days is Europa. Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. That's what Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system, looks like. And the coolest thing about this faraway place, it might host life. Astronomers consider Europa to be one of the most promising places in the solar system to search for new forms of life. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it's still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. For a long time, scientists have been wondering about Jupiter's X-ray auroras. What causes them? It seems like the 40-year-old mystery has been solved. Jupiter's breathtaking X-ray auroral emissions are triggered by electrically charged particles called ions. They crash into the gas giant's atmosphere, and here's the result. But astronomers couldn't understand how those ions got to the atmosphere in the first place. But recently, they've seen the ions surfing Jupiter's magnetic field all the way down to the planet's atmosphere. Astronomers have received this data thanks to NASA's Juno spacecraft and ESA's XMM Newton telescope, situated in Earth's orbit. Now, on our home planet, auroras are only visible in a belt surrounding the magnetic poles. between 65 and 80 degrees latitude. Anything beyond 80 degrees and auroras disappear. But Jupiter's X-ray auroras are much more inconsistent. They pulsate regularly poleward of the main belt, and sometimes they're different at the north and south poles. Scientists have figured out that this pulsation is caused by the fluctuations in Jupiter's magnetic field. You see, when the planet rotates, it drags behind its magnetic field. Struck by the particles of the solar wind, it gets compressed. This heats the particles trapped in Jupiter's magnetic field, and they start moving along the magnetic field lines, producing magnificent auroras. Another feature Jupiter is famous for is its Great Red Spot, an enormous storm raging in the southern hemisphere of the gas giant. Its top parts tower more than 5 miles above the surrounding cloud tops. The storm is more than twice as wide as our planet. At the edges of the storm, the wind speeds reach 270 to 420 miles per hour. That's faster than Earth's tornadoes. The hot gases in the planet's atmosphere are always moving, rising, falling, and swirling. Just like on our planet when cooler and hotter gases mix and merge into one another, they form giant circling storms. Astronomers think that once several enormous storms could have come together, creating the Great Red Spot. And now it keeps raging by constantly drawing cool gases from below and hot gases from above. Plus, this monster of a storm absorbs other, smaller vortices. They make the spot even more powerful. Several theories try to explain why the storm has its trademark color. It varies from whitish and pale salmon to orange and brick red. Some scientists believe the answer lies below the Great Red Spot, closer to the planet's surface. A colorless layer of ammonium hydrosulfide might be reacting with the cosmic rays or the UV radiation coming from the sun. This somehow gives the spot its pretty red color, but so far, it's just a theory. Astronomers have been observing the Great Red Spot since the 1830s. And for the first time, the storm was spotted in 1665 and described as the permanent spot. In other words, the storm is almost 400 years old. Strangely, it's been shrinking in size since the beginning of the 21st century. In 2019, it began flaking at the edges, with small pieces breaking off and vanishing. If this process continues, by 2040, the Great Red Spot might become circular, or it may simply disappear.
Uh-oh, hurricane alert! Everyone's hiding! The speed of the wind outside is more than 75 miles per hour. Seems like a lot, but this storm is moving at 400 miles per hour. Wait, do such speeds exist? Yep, but to see a storm that fast, you'll have to travel to Jupiter. So let the journey begin. The planet is huge. Almost 1,300 Earths could fit into this gas giant. It's also incredibly hot, with the temperatures reaching about 43,000 degrees Fahrenheit at the planet's core. Unfortunately, you can't land on Jupiter's surface because, well, being a gas giant, it doesn't have any solid surface. But you can go deeper into Jupiter's atmosphere. Look at these thick brown, yellow, red, and white clouds passing by. They're what make the planet look colorful and kind of striped. If you continue descending toward the center of the planet, you'll see its atmosphere, mostly made up of hydrogen and helium gas, becoming liquid. It happens because of immense atmospheric pressure. The planet's core itself is a mysterious object. Scientists still haven't figured out whether it's a molten ball of thick liquid or a solid rock 14 to 18 times the mass of Earth. Anyway, exploring Jupiter isn't the main goal of your trip. No, you've arrived here to see the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts are towering more than 5 miles above the tops of the surrounding clouds. The storm is 1.3 times wider than our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot. And it turned out that this monster of a storm goes more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere, and keep in mind that Jupiter's temperatures are minus 234 degrees Fahrenheit in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. There, the heat reached 2,400 degrees. This temperature is higher than that of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating, but the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear entirely, but that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. The change in the wind speed is no more than 1.5 miles per hour during one Earth year. It's a tiny change, but however small the difference is, it still means a lot. The wind speed at the edges of the storm can reach a mind-boggling 400 miles per hour. That's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. Scientists faced lots of challenges when they were trying to understand the mystery that was the Great Red Spot. It's unclear what fuels the storm. Can it be the nature of the storm's home planet? Since it's a gas giant, Jupiter doesn't have any solid ground, so there's no friction, which might be the only thing that could make the storm weaken. The hot gases in the planet's atmosphere are always moving, rising, falling, swirling, just like on our home planet, where cooler and warmer air mix and merge into one another, forming giant circling storms. Astronomers think that once, several enormous storms could have come together and created the Great Red Spot. And now, it keeps going by constantly drawing cool gases from below and hot gases from above. Plus, the storm might be absorbing other smaller vortices. This makes the Great Red Spot even more powerful. Unfortunately, thick clouds on Jupiter don't allow astronomers to see what's going on in the planet's lower atmosphere. Scientists have been speculating on what may hide beneath the Great Red Spot for decades. Is it a massive volcano? Unlikely. Jupiter is mostly made up of gases, and it doesn't have a crust that could crack, letting lava escape from the planet's interior. There are also a few theories explaining why the storm has its trademark color. It varies from whitish and pale salmon to bright orange and brick red. Some scientists believe the answer lies deep below the Great Red Spot, closer to the planet's surface. A colorless layer of gas might be reacting to the UV radiation coming from the sun. This is probably what gives the storm its red color. But so far, it's just a theory. Hey, your guess is as good as mine, huh? Jupiter isn't the only planet that can boast having a giant storm. Another one, as wide as our home planet, rages on Saturn. It's called the Great White Spot. How clever! The storm has a tail of white clouds encircling the entire planet. It occurs every 30 years or so. The storm indeed starts as a spot, but then it starts stretching and stretching. Astronomers have figured out that the Great White Spot is actually a huge system of thunderstorms. At the top of the storm, lightning can flash more than 10 times per second. But the main mystery about the Great White Spot is where it gets its energy from. Some scientists think it may be powered by the sun. Others argue that the storm's cloud pattern only makes sense if there's an internal source of heat that can power the winds. Anyway, severe storms on different planets of the solar system aren't the only space mystery that makes astronomers scratch their heads. Let's move to Pluto, the largest known dwarf planet in the solar system, and explore its atmosphere. It rises really high above the surface of the planet and has more than 20 layers, all of them freezing cold and extremely condensed. By the way, our moon also has some sort of an atmosphere. Called an exosphere, it consists of helium, neon, and argon. It's 10 trillion times less dense than Earth's atmosphere. While traveling through space, watch out for black holes. Woo! A black hole is a place where gravity is so strong that even light can't get out. But black holes can sometimes behave like a massive galactic volcano. From time to time, they flare up. Sounds like me. But instead of spewing lava, they produce enormous amounts of energy. And this phenomenon leaves gaping holes in the surrounding material and gas. A short while ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater this event left behind could fit 15 Milky Way galaxies. Yeah, I can't get my head around that either. During your space voyage, think twice before landing on unknown planets. Otherwise, you may end up in a place like K2-141b. That's a planet outside of our solar system. At first glance, it's not that different from Earth. It has liquid oceans that evaporate, form clouds, condense, and get back to the surface as rain. But instead of water, it rains rocks. The surface of this exoplanet is covered with lava seas dozens of miles deep. The temperatures on the K2-141b reach 5,000 degrees during the day. That's toasty enough for the magma in the oceans to vaporize into the atmosphere. Then, supersonic winds, which can move at the speed of 1 mile per second, carry this rock vapor into the planet's night side. The vaporized magma cools down, becomes liquid again, and falls as a rocky rain. Not a vacation spot. Too hot. I'll pass.
You're standing in a room full of explosive gas. One spark could cause an explosion so powerful that all the windows and doors would be just blown out with a huge column of fire. And you're holding a match. You need a bigger target than this room. How about the largest room of explosive gas in our entire solar system? Meet Jupiter. It's the 5th planet from the Sun, and the largest one in our system. It's 11 times the width of Earth, and almost 2.5 times heavier than all the other planets in our solar system combined. If we put Jupiter on the scales, we would need about 317 Earths to balance it. But most importantly, it has a lot of methane in its atmosphere. It's the gas we use in our kitchen, or fill up our car with, and it burns just fine. More importantly, there's metallic hydrogen. In its normal state, hydrogen is the lightest element in the universe, but on Jupiter, it's at great pressure, more than 400 million atmospheres. By comparison, on Earth, you feel the pressure of 1 atmosphere. So multiply that by 400 million, and hydrogen is compressed so much that it looks like liquid metal. Metallic hydrogen can be a great fuel. It'll give off 20 times more energy than burning ordinary hydrogen. So you and your match can have great fun out there. Okay, here we go. The first problem is distance. Jupiter is only 1 planet away from us, but the path is also blocked by the asteroid belt behind Mars. It's full of giant rock debris. On average, each asteroid could be as wide as the distance from Los Angeles to Las Vegas. There's rocks the size of an entire state. And the biggest asteroid of them all is Ceres. It's almost as wide as Alaska. It's even considered a dwarf planet. And this dangerous journey to Jupiter takes about 650 days. That's almost 2 years of boredom inside a spaceship. By comparison, the longest time astronauts have spent aboard a spaceship is 84 days. But we'll let you take your favorite DVD collection and a couple bags of popcorn. At the end of the day, you'll be able to get some sleep after a hard day at work. Fast forward 2 years into the future, and you've arrived at your destination. You're already imagining lighting a match at the surface of Jupiter, exploding it like a balloon. Oh, be careful when you get close to it. Because of Jupiter's great weight, it has a strong gravitational force, about 3 times stronger than back home on Earth. The closer you get to its surface, the weaker you feel, and you can even barely stand on your feet. The maximum weight you can lift here is also 3 times less, and even a match you're holding in your hand already feels heavier. If you try to jump up, you need more effort. Actually, you can't even do that because Jupiter is a gas giant. That means it has no solid surface. Theoretically, the deeper you dive into these clouds, the more pressure you'll feel. Gradually, the clouds and gases thicken and form a kind of liquid. But you don't have to dive that deep. Methane is a light gas, and it's closer to the surface. So, this is the moment of truth. You take a match, you flick it on the box, and nothing happens. Well, let's give it a couple more tries. Second match. Third. Nothing works. Okay, you've got a gas burner in your backpack. You unscrew the valve to maximum, and nothing happens again. Well, that's because it takes 3 components to start the combustion process. The first is fuel. Luckily, there's enough methane and metallic hydrogen on Jupiter to blow up the whole planet in a matter of seconds. The second component is the ignition source. It's the initial force that will start the combustion process. It could be a spark, an electrical discharge, or a match like the one you have in your hand. And the last ingredient is oxygen. Yes, the same oxygen that we breathe. It's just as important to fire as the fuel itself. For an experiment, try lighting a small candle. Now cover it with a glass. You see how the fire keeps burning for a few seconds and then goes out? The fuel is still there, but the fire has used up all the oxygen inside the glass, and the burning process is over. The same thing happens on Jupiter. There just can't be fire, simply because there's no oxygen. And you didn't even have to fly there to find that out. From Earth, we can see hundreds of thousands of little meteorites falling on Jupiter. The asteroid belt next to it is to blame for this. When they hit its atmosphere, they start to burn, and that doesn't instantly blow up the entire planet. But don't be upset. There's still a way to ignite this gas giant planet. All you have to do is trigger a thermonuclear chain reaction on the planet. Then, there'll be an explosion so powerful, it'll be visible from Earth, and it will be like the birth of a new star. To do that, we need to detonate a nuclear reactor, like the ones that give us electricity here on Earth. In fact, we'd have to send everything we have to Jupiter, but even that won't do the trick. Big asteroids, when they hit the planet, cause a much bigger explosion. In 2009, a meteorite the size of 5 soccer fields hit Jupiter. It caused an explosion of 5 billion tons of TNT. This incident left a dark spot the size of the Pacific Ocean. And an even bigger explosion happened there in 1994. After that collision, there was a giant spot on Jupiter, almost the size of our planet. But strong winds and storms quickly began to sweep away the traces of the explosion. After a few weeks, Jupiter looked like normal. The problem is that our attempts to blow up the gas giant took place on the planet's surface. We need to plant a charge the size of the moon deep below. A massive explosion will cause a thermonuclear reaction and cause the metallic hydrogen to detonate. The explosive process is set, and within seconds, Jupiter explodes like a giant balloon. But this spectacle will be the last one that humanity ever sees. The explosion would disturb the stable orbits of Earth and the other planets. The trajectory of Earth around the Sun might change, and we may see the dawn not in the east, but on any other side of the world. When the strong wind from the explosion reaches the Earth, it'll start scraping our atmosphere. Soon, our planet will lose its ozone layer. It was our shield that protected us from solar radiation. In such a situation, we'll have to hide underground for the rest of our lives. But even this can't protect us. Before long, the Earth will be showered with thousands of meteorites. Jupiter was so heavy that it held the asteroid belt in place. Without it, the asteroids would start flying towards us. Earth would feel a constant meteor shower. But there would be no one left on Earth to observe it anymore. Jupiter's explosion can be compared to a supernova. In fact, Jupiter is practically a star. If it were just a little bigger and heavier, it would start to shrink. The intense pressure on the planet's core would start thermonuclear reactions. Eventually, Jupiter will have turned into a brown dwarf, and it would be 50 times heavier than it is now. But because it doesn't have enough weight to do that, Jupiter is sometimes called a failed star. Well, maybe we should visit other gas planets in our solar system and try to light our match there. Saturn. Saturn's atmosphere is similar to Jupiter, but there's no oxygen for combustion there either. So all you have to do is admire the planet's beautiful rings and move on. Well, Uranus and Neptune are much smaller, and they don't have metallic hydrogen, so their explosion wouldn't be as strong. But you still wouldn't be able to ignite them with a match, because there's no atmosphere full of oxygen. But there is one planet where you could light a fire with your match. It's GJ1132b, and it's 39 light-years away. Scientists think it might have oxygen on it, although it's not a gas giant that has combustible gases in its atmosphere. But you can still sit on its rocky ground and make a fire to admire the unusual sunset.
Why do we love Saturn so much? Right, because we love its amazing rings. The planet stands out in the solar system because of them. The major rings have a diameter of 170,000 miles, yet their thickness does not exceed 330 feet. Saturn's slowest outermost ring spins at about 37,000 miles per hour. It's slower than the rotation of Saturn itself. But did you know that Saturn was ringless for most of its history? Let's find out how they were formed. Using Cassini's final plunge into the planet, researchers could estimate the ring's mass, 33 billion pounds. Further, they have determined that the rings were between 10 to 100 million years old, much younger than the planet itself. The thing is that the rings only look solid. They are made of billions of rock and ice chunks. They are primarily tiny ones, looking like grains of sugar to those as large as a house, or even as mountains. The innermost chunks of ice and rock shoot through space at about 52,000 miles per hour. There are mysterious spokes in its rings. It seems they form and disperse within a couple of hours, and these spokes might consist of electrically charged sheets of tiny particles formed when small meteors hit the rings, or maybe electron beams from Saturn's lightning. One theory says Saturn's rings have formed all that extra material that remained after Saturn began, which is a material that couldn't create a moon. There's also a theory that says there was Theia, a Mars-sized planet that collided with Earth about 4.5 billion years ago. Lighter crust parts ended up in space during the impact, whereas its denser core stayed behind. But in the case of Saturn, all that debris perhaps didn't put a new moon together, but it formed rings many people today recognize this planet for. Another theory is that rings formed from dust and debris of a moon that ended up destroyed by this big impact, maybe by an asteroid or comet. Or perhaps the rings are there because once a moon fell apart because of the tidal forces coming from its parent planet itself. If these rings formed at the same period as Saturn did, they would have had more than 4 billion years to collect a bit of debris and dirt coming from micrometeorite collisions. But these rings mainly consist of water ice, no dirt at all, which means they're younger than expected. And the nature of this ring system tells us a thing or two about Saturn's fuzzy inside. Fuzzy means its core is like sludge. The helium and hydrogen in Saturn mix with more and more rock and ice over time the closer you go to the planet's core. It's similar to what you see in our oceans. The deeper you go, the level of saltiness increases. But the rings may disappear in the far future. Rings are generally more common than we think. Jupiter, Uranus, and Neptune all have their own ring system. But not every planet has the same ones. Saturn has a fascinating halo, and definitely the most spectacular rings, true. Others mostly have rings made of dust and rocky particles, and not just planets. Other space bodies can have rings, like the asteroid called Chariklo. But even though the gas giants of our solar system have rings, rocky or so-called terrestrial ones don't. And one theory says it might have been that way because gas planets in the outer area of the solar system protected those rocky ones that formed in the inner solar system from all those collisions that possibly could have formed rings around them. Or it could be because gas giants are way bigger and their enormous volume allows them to have a ring system that can remain stable. And what if Earth had rings in the past too? Maybe in the time of the big collision when our moon could have been formed. Now to some more cool things happening in our solar system. Pluto, a tiny dwarf planet at the edge of our solar system, also the one we used to call a planet, has a pretty bizarre atmosphere. No one expected to see a haze there go as high as 1,000 miles. That means it rises higher above the surface of the atmosphere of our home planet. And the atmosphere on Pluto has around 20 layers. They're more compact and way cooler than scientists expected, and tons of nitrogen gas escape Pluto by the hour. But the dwarf planet still finds a way to constantly create new supplies of all the nitrogen it had lost. One theory says it probably produces these supplies through geological activity. Our moon is pretty peaceful, but that's not something we can say for Io, one of Jupiter's moons. This one has hundreds of volcanoes. It's the moon with the most volcanic activity in our solar system. Io sends plumes of sulfur up to an incredible 190 miles into its atmosphere. Its volcanoes emit many particles and gases into the space right next to Jupiter, every single second. Its eruptive activities happen because of Jupiter's mighty gravitational forces and magnetic field. The insides of Io tense up and relax all the time, depending on how close or far away it is from Jupiter. And that's why it generates enough energy to have such an eruptive nature. Speaking of volcanoes, Mars has one larger than the whole state of Hawaii. At first, you'd probably say it's a quiet and peaceful planet. But once upon a time, enormous volcanoes dominated its surface. Yup, that includes a well-known Olympus Mons, the largest volcano ever found in our entire solar system. 374 miles across, comparable to the size of Arizona. Olympus Mons is 16 miles high, 3 times the height of our tallest mountain, Mount Everest. And by its volume, this volcano is 100 times bigger than the largest one on Earth. Mars can have such big volcanoes because its gravity is significantly weaker than the one on our home planet. Also, the crust on Earth moves all the time, unlike the Martian crust. Do you know how the Hawaiian Islands formed? A hot spot in the mantle created a chain of volcanoes in the crust floating above it. A Martian volcano may grow bigger because its surface isn't moving, so a volcano could build up for a longer time in just one spot. Miranda is one of the most bizarre moons in the outer part of our solar system. It's a shadowy moon that orbits Uranus with many craters, sharp ridges, and similar disruptions on its surface. Usually, this type of relief tells a certain area used to have a lot of volcanic activities. But that wasn't the case with Miranda. Also, this moon is way too small to generate tectonic activities, another element that could form this type of surface. One theory says the gravitational force from Uranus could have caused the push-pull action, something that made all these bumps on Miranda's surface. We'll have to send another spacecraft to find out what was happening there. We are all made of stardust. 97% of atoms we're made of are the same as the material our galaxy consists of. The building blocks of life is a term we use for a group of elements that are vital for life on Earth. And stars have these elements too, but in different proportions. For instance, we are 65% oxygen by our mass, whereas elements we measure in space, like the spectra of stars, have less than 1% of oxygen. So, Mercury is already the smallest in our solar system in the planet category, excluding some other bodies like the dwarf planet Pluto. And now it looks like it's still shrinking. It's the second densest after our planet, but it's getting denser over time. Researchers thought the Earth was the only planet in our solar system with tectonic activities for a long time. And now we know Mercury is tectonically active too. Messenger spacecraft managed to map the whole planet. Scientists realized the planet is full of fault scarps, some cliff-like landforms. Since these are relatively small, they're probably young, and Mercury is still contracting even 4.5 billion years after our solar system was formed. Do you recognize this majestic world? The second largest planet from the Sun? Check. A gas giant with a hazy yellow-brown appearance? Check. 7 huge, intimidating rings? Check. You're right, it can't be anything else but Saturn. And recently, the Hubble Space Telescope has made an astonishing discovery. Apparently, the planet's rings have been doing something to the planet for a long time. a new study has revealed that these iconic rings are heating Saturn's upper atmosphere. The coolest thing, though, is that researchers from NASA claim that it's something scientists have never observed anywhere else in our solar system. This secret has been hiding in plain view for 40 years, and only after using the observations of the planet received from the Hubble Space Telescope and retired Cassini probe and Voyager 1 and 2 spacecraft did astronomers figure it out. This unexpected interaction of the gas giant with its rings could become a tool for predicting if planets in other star systems have magnificent Saturn-like ring systems as well. So, how did it become clear that the gas planet is being slowly cooked by its own rings? The telltale evidence is an excess amount of ultraviolet radiation. It can be seen as a spectral line of hot hydrogen in the atmosphere of the gas giant. There's a bump in radiation that can only mean that something is heating the upper atmosphere from the outside. It's still kinda unclear how this process is happening, but the most probable explanation is that icy ring particles rain down on Saturn and cause this heating. But it might also be the impact of tiny meteorites or the particles of solar wind. The heating could be caused by solar ultraviolet radiation, or some electromagnetic forces that pick up electrically charged dust. When NASA's Cassini probe finished its mission and plunged into Saturn's atmosphere, it had enough time to measure the atmospheric components. And it turned out that many particles were indeed falling from its rings. But in any case, the heating process happens under the influence of the gravitational field of the gas giant. You see, astronomers do know about the slow disintegration of Saturn's rings, but figuring out how this process affects the planet, that's new. Now, do you remember NASA's Cassini spacecraft I mentioned before? For more than a decade, it was studying Saturn, sharing images of the gas giant and its icy moons. It took us to marvelous worlds where methane rivers ran into methane seas, and jets of gas and ice were blasting material into space. Anyway, that very Cassini also studied Saturn's magnetosphere. The thing is, forces acting deep inside the planet produce a ginormous magnetic bubble under the planet. And this bubble is called the magnetosphere. Unfortunately, astronomers still have very little information about this phenomenon on Saturn, since magnetic fields are invisible and are, of course, best studied from within. Imagine this: million-mile-per-hour flows of electrically charged particles from the sun, aka solar wind, are spreading through the solar system. Suddenly, something appears in their way. Oh, it's Saturn's magnetic field. It protects the planet, making solar particles back away. As a result, the sun's magnetic forces are raging outside Saturn's magnetosphere, while inside the gas giant's protective bubble, its own magnetic forces dominate. Our home planet also has a magnetic field, but it creates a much smaller magnetosphere. And still, it effectively protects us from the harmful particles coming from the sun and from space. But even though Saturn is protected by its magnetosphere, the sun still manages to mess with the planet. Energetic winds from our star sweep over the gas giant, causing massive auroras. But unlike auroras here, on Earth, Saturn's auroras can only be seen in ultraviolet light. In other words, they're invisible from Earth's surface. You can only see them if you travel to space. But apparently, there are different kinds of auroras on the gas giant. For example, one more type is triggered by the charged particles coming from volcanic eruptions on the planet's moons. And some of Saturn's auroras might be caused by powerful winds swirling in the planet's own atmosphere. These winds blow in the ionosphere, which is a region located beneath the magnetosphere. The same winds might be responsible for the variable rotation rate of the planet. This phenomenon makes it difficult for scientists to figure out how long one day on the ringed planet lasts. Speaking of winds, Saturn has a mysterious vortex swirling over the planet's south pole. The whole thing resembles an enormous hurricane-like storm on Earth, but its eye alone measures almost 2,500 miles across. For comparison, the eye of a typical terrestrial hurricane is a mere 2 to 3 miles wide. What confuses astronomers is that although the phenomenon looks like a hurricane, it doesn't behave like one. It's stationary and keeps spinning over the same area of the South Pole. And while polar vortices on Earth have cold cores, the one on Saturn is warm. And now, brace yourself for another surprise Saturn has prepared for us. In an image sent to Earth by the Hubble Space Telescope, one can notice a couple of dark, shadowy spots on the left side of the planet's rings. Those are informally called spokes, maybe because they resemble spokes on a bicycle. The shading and shape of spokes vary. They may seem dark or light, it depends on the angle and illumination. Sometimes they may even look like blobs rather than something with a classical radial spoke shape. They also don't last long. But the good news is more and more will start to appear the closer we are to May 6, 2025. That's when the autumnal equinox on Saturn will occur. Now, on Earth, that's the moment when the Sun is exactly above the equator of the planet, and day and night are of the same length. But on Earth, it's something a bit different. Like our planet, Saturn is tilted on its axis. That's why it has 4 seasons. But since the orbit of the gas giant is much larger, each of these seasons lasts about 7 Earth years. An equinox occurs when Saturn's rings are tilted edge-on to the Sun. But what causes the spokes? Astronomers think it might be the gas giant's magnetic field. When a planetary magnetic field interacts with the solar wind, it creates an electrically charged environment. As we already know, on Earth, this results in northern lights, also called Aurora Borealis. And if we speak about Saturn, the tiniest icy ring particles might get charged too. And it probably temporarily levitates these particles above the larger boulders in the rings. For the first time, the spokes in Saturn's rings were spotted by NASA's Voyager mission. It happened in the early 1980s. At that time, we didn't know that these spokes were a seasonal phenomenon. Voyager 2 just passed by the planet after all, and then sped on. To figure out what these spokes were and how they functioned, astronomers needed a space telescope that could observe Saturn's rings from afar, like Hubble. The latest equinox on Saturn occurred in 2009. That's when the Cassini space probe was traveling around the gas giant. It sent many amazing images back to Earth. It managed to prove quite quickly that the spokes weren't caused by gravitational interactions with Saturn or the influence of the gas giant's moons or small moonlets, which make up the planet's rings. It was the year 2005 when Cassini confirmed that the spokes were related to Saturn's magnetic field. And even though that mission was finished in 2017, now Hubble keeps its long-term monitoring of the changes on and around Saturn. Despite all the observations, astronomers still can't predict the beginning and duration of the spoke season. Luckily, Saturn's prominent rings are a perfect laboratory for studying this phenomenon, because even though other gas giants in the solar system also have rings, those are not so visible. And scientists don't know whether spokes occur on those planets.
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa, and scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet, and it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas, and where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
Hey, wake up! Quick, listen to that. It's a 5-second FM signal coming from one of Jupiter's moons. You fumble for your phone and inform your colleagues. They freak out over the news and rush to the lab. You've been a scientist working with the Juno probe, exploring Jupiter for years. But this is the first time you've witnessed something so unusual. Ganymede is Jupiter's largest moon and the biggest moon in our solar system. If this space body didn't orbit around Jupiter, it would be classified as a planet. It's even bigger than Mercury and Pluto. What makes this moon stand out among others is the fact that it has its own magnetic field. The moon was born around 4.5 billion years ago. It means it's as old as Jupiter itself. This planet-sized space body takes 7 Earth days to orbit its planet. Everyone gathers at the laboratory, impatiently waiting for you to play the recording of the signal coming from space. Your colleagues get their game on, trying to figure out what the source of this mysterious sound is. Around 40% of Ganymede's surface is dark, with craters scattered around, and 60% is light-colored. There are formations that were probably caused by tectonic activity or the release of water from under the surface. Scientists managed to discover a thin layer of oxygen trapped in the moon's atmosphere. The temperatures there are super low, between -170 to -200 degrees Fahrenheit. There isn't much information about how the moon behaves or what chemical elements it hides inside. Some of your colleagues try to create the same conditions that existed when the sound was transmitted. For hours, they sit there waiting, but nothing. Maybe it was a fluke. You get to the control system and activate the Juno spacecraft. The main point of this mission is to observe Jupiter's gravity, magnetic fields, the atmosphere, and the planet's evolution. By the way, there's also some evidence that Jupiter's largest moon is evolving too. Since it has a magnetic field surrounding it, auroras pop up all the time. Those are glowing gas circling the moon's north and south poles. If life existed in such a place, it would probably be at the bottom of Ganymede's extremely salty ocean. For a long time, scientists thought that the sun was a crucial component to kickstart life. But now we know that there are organisms dwelling deep at the bottom of the oceans. Those are doing just fine without sunlight. The oceans of our planet are teeming with some of the most bizarre creatures of all shapes and sizes. Sea lilies live some 10,000 feet underwater. They got their name because they look like flowers, except they're not plants, but animals. Don't be fooled by their stems and leaves. Those are body parts equipped with nerve endings to detect food around them. Goblin sharks are probably some of the most weird-looking sharks that live at the bottom of the ocean. They can grow up to 12 feet long and have a very unusual snout. Now, take a look at the anglerfish. It has a bioluminescent blob on its head to attract prey and navigate its way around the dark ocean floor. It's a natural flashlight that never needs new batteries. It's only the females that have these flashlights, though. The blobfish is another bizarre animal living down there. It lives in the Atlantic, Pacific, and Indian Oceans, 9,000 feet under the surface. Anyway, even though you asked everyone to keep the news confidential, it somehow leaks to the media and becomes a new trending topic. You get a call from a news agency. They say they want to interview you about this breakthrough that may prove life exists in outer space. The next day, you head down to the news station to talk about your discovery. You have a whole live studio audience watching your every move as you reach out to grab your glass of water. The crew scurries around doing some last-minute checkups before you're live on air. The makeup artist does some final brush-ups. The sound engineer asks you to test your mic once more. Several of the producers are sitting in the front seats. Bright lights are flooding the studio. The countdown begins. 3, 2, 1, and you're introduced, and the host asks you to explain what it was that you heard. You tell them about the Juno space probe orbiting Jupiter. After a couple of questions, the host finally brings up the most dreaded one. Might the mysterious sound be coming from another civilization? Everyone leans in, waiting for you to answer. You freeze, not knowing what to say. Even though the crushing pressure at the bottom of the ocean is 1,000 times stronger than at sea level, life still exists there. Algae, which is considered a delicacy in the ocean world, is off-menu for deep-sea creatures due to a lack of sunlight. Many of these bottom dwellers have to munch on leftovers instead. Those sink down there from the upper layers of the ocean. The freezing temperatures and the intense pressure have altered the cells of these creatures. This has made them more resilient than the average fish. Bacteria were developing their own ways of surviving. Studies show that they feed on certain gases and chemicals, like sulfur and carbon dioxide. Methane and hydrogen are released when tectonic plates move against each other, and some of these bacteria feast upon those gases too. Tardigrades, also known as water bears, are microscopic critters that can live and thrive in extreme conditions. You can find them in volcanoes, frozen glaciers, and even in the empty void of space, which means that some life forms might actually exist on Ganymede. You explain this to your audience. Then you mention that you don't have enough information to determine if it was another civilization or a natural phenomenon that produced the sound. This doesn't mean that the bottom of Ganymede's freezing oceans isn't teeming with its own bizarre and weird creatures. There might be some legendary beasts like the Kraken or Leviathan there, or weird glowing fish with 2 heads, a fish with tentacles and a large fin, giant crabs. The bacteria there might be as varied as our own. The plants, if they exist there, have to be strong enough to survive the sub-zero temperatures. The animals on Jupiter's largest moon could be as big as our blue whales or as tiny as plankton. After the interview, you head back to the lab to examine the records once more. On your way home, you see posters of yourself with captions like, "Are we not alone?" Hey, you've become a celebrity. Many people take pictures of you. You've been booked by other agencies for more interviews. Some science magazines even want to put you on the front cover as the Person of the Year. Every time you come to work, you wait for the sound to appear again. But nothing. You send a signal from the Juno probe, trying to make some sort of contact with whatever produced the sound. Nothing. That night, you pass out on your desk once more. Eureka moment wakes you up in the middle of the night. There might be something you've missed. You run the numbers again and realize that the answer was in front of you this whole time. It wasn't another civilization that produced this sound. The source was electrons. Every planet produces its own sound. It's created when charged particles from the solar wind and the planet's magnetosphere interact with one another. That's what happened on Ganymede. The electrons in its magnetic field, where the probe picked up the signal, were acting stranger than usual. and this amplified some irregular frequencies. You're embarrassed and spend the rest of your night making phone calls, telling your team the news. The agency that interviewed you releases a statement. They explain that other civilizations aren't trying to contact us. You sit back at your desk, waiting for the next big thing to happen. Europa is another of Jupiter's moons that may host life. It's made up of an iron core, a mantle, and a salty ocean, twice the volume of all the oceans on Earth. And just like Ganymede, the ocean lies under a water ice crust. Scientists claim that there might even be active volcanoes there, and some resilient bacteria may live there. With enough water, certain chemicals, and a source of energy, Europa could produce life. But it's unlikely that we'll find anything but tiny microbes.